Welcome everyone to our presentation on 5G technology, the next generation of wireless networking that's revolutionizing our digital world. This opening slide sets the stage by highlighting the futuristic, high-tech atmosphere that 5G is ushering in, with its advanced infrastructure and dynamic digital connections. We'll be exploring the transformative potential of 5G and examining how it's poised to reshape our lives and industries in the years to come. The vibrant, technological imagery conveys the excitement and promise of this cutting-edge technology. Let's dive in and discover how 5G is paving the way for a more connected, intelligent, and innovative future. 5G is the latest evolution in mobile network technology, building on previous generations from 1G to 4G. It's a global standard developed through international collaboration, enabling worldwide compatibility. 5G is more than just faster phones. It creates a foundation for connected devices, smart cities, and automation. The transformative power of 5G goes beyond personal use cases, unlocking new possibilities for industries and society. The evolution of mobile networks has been a remarkable journey, transforming the way we communicate and interact with the world. In the 1980s, 1G networks were introduced, providing analog voice-only capabilities with limited coverage and quality. The 1990s saw the rise of 2G networks, which brought digital voice and the introduction of text messaging, as well as the Global System for Mobile Communications, GSM. The 2000s ushered in the 3G era, enabling mobile internet, video calling, and the proliferation of smartphones. The 2010s witnessed the arrival of 4G networks, delivering high-speed data, mobile streaming, and the flourishing of the app economy. Now, in the 2020s, we are experiencing the transformative power of 5G, with its ultra-fast speeds, massive connectivity, and extremely low latency, revolutionizing our digital experiences. 5G offers ultra-fast speeds, with theoretical peaks of 20 gigabits per second, allowing you to download movies in just seconds. It has ultra-low latency, as low as 1 millisecond, providing near real-time responsiveness. 5G supports massive device connectivity, with the ability to connect up to 1 million devices per square kilometer. The network is highly reliable, with 99.999% availability for mission-critical applications. The world is generating more data than ever before, with global data creation expected to reach 175 zettabytes by 2025. 5G provides the massive capacity needed to handle this exponential growth. 5G enables new applications that require high bandwidth and low latency, like virtual reality, remote healthcare, and industrial automation. This will unlock a new wave of innovation. 5G is the foundation for smart infrastructure powering connected cities, intelligent transportation systems, and industrial automation. This will drive greater efficiency and productivity. Analysts estimate that 5G will generate $13.2 trillion in global economic value by 2035, fueling economic growth and job creation around the world. 5G offers significantly faster peak download speeds compared to 4G and previous generations, reaching up to 10-20 gigabits per second. 5G has much lower latency, with just 1 millisecond compared to around 50 milliseconds for 4G and 100 milliseconds for 3G, enabling real-time responsiveness. 5G operates on a wider range of frequencies, from sub-6 GHz up to 100 GHz, allowing for greater flexibility and capacity. 5G supports a much higher device density, with the ability to connect up to 1 million devices per square kilometer, compared to 2,000 for 4G and just 60 for 3G. These advancements in speed, latency, frequency, and device density make 5G a transformative technology that will enable new applications and use cases. 5G uses higher frequency radio waves than previous generations, including millimeter waves that enable ultra-fast data transfer. The 5G network is made up of thousands of small, low-power base stations that create a dense coverage area, overcoming the limited range of higher frequencies. 5G uses OFDM, orthogonal frequency division multiplexing, to encode data on multiple carrier frequencies, maximizing efficiency and throughput. Beamforming technology focuses the 5G signal energy directly toward devices, rather than broadcasting in all directions, improving signal quality and reducing interference. 5G is enabled by several key technologies that improve speed, capacity, and reliability. OFDM divides data streams across multiple carriers, allowing more efficient transmission of data. Massive MIMO uses many more antennas than previous generations, multiplying capacity and improving reliability. Network slicing creates multiple virtual networks on shared physical infrastructure, allowing tailored services for diverse needs. These technologies work together to deliver the transformative capabilities of 5G. 5G networks utilize a range of spectrum bands to deliver different capabilities. The high band or wave spectrum operates between 24,100 GHz. This provides ultra-fast speeds, but has very limited range and has trouble penetrating buildings. The mid-band spectrum, between 1–6 GHz, offers a good balance of speed and coverage. The low-band spectrum, below 1 GHz, provides the widest coverage and can better penetrate buildings. Different 5G use cases will leverage the unique characteristics of these spectrum bands to optimize performance. The 5G network architecture consists of several key components that work together to provide high-speed, low-latency connectivity. User equipment like smartphones and connected devices access the network. The radio access network, with base stations, connects these devices to the core network. The 5G core, with its cloud-native, service-based architecture, manages the connections. Edge computing resources distributed throughout the network reduce latency for applications that require fast response times. This integrated architecture is designed to deliver the performance and capabilities that 5G promises. The key difference between non-standalone (NSA) and standalone (SA) 5G deployments is the network architecture. NSA uses 5G radio with an existing 4G core network, allowing for faster initial deployment and leveraging existing infrastructure. However, it has limited 5G capabilities. SA, on the other hand, is a complete 5G system with both 5G radio and 5G core. This provides the full performance benefits of 5G, including advanced network slicing, ultra-low latency, and a cloud-native architecture. NSA is a transitional architecture, while SA represents the full potential of 5G technology. The choice between NSA and SA depends on the specific needs and timeline of the deployment. NSA can be a good starting point, with the option to migrate to SA as the technology matures. The 5G core network is made up of several key components that work together to provide connectivity and services. User equipment (UE) refers to the 5G-capable devices that connect to the network, such as smartphones, IoT sensors, and more. The ING-RAN, or Next Generation Radio Access Network, connects these devices wirelessly using G-Node B base stations. The core network functions include the user plane function (UPF), access and mobility management function (AMF), and session management function (SMF). Additional support functions handle data management, policy control, and security for the overall network. This detailed architecture diagram shows how these components are connected and interact within the 5G core network. Small cells are compact wireless transmitters that create a dense network fabric across a city or building. Hundreds of small cells may be required per city block, much more than traditional large cell towers. This dense network approach dramatically improves network capacity and internet speeds for users. The small size of small cells allows them to be installed unobtrusively on streetlights, utility poles, and building exteriors. Small cells provide coverage and capacity where it's needed most, unlike large towers that cover a wider but less dense area. The images show examples of different small cell deployments on street lights, in buildings, across an urban landscape, and a size comparison to a traditional tower. Network slicing allows us to create multiple isolated virtual networks on a shared physical infrastructure. Each slice functions as an independent network, tailored to the specific needs of different use cases. Slices can be optimized for things like latency, bandwidth, security, and reliability to meet the unique requirements of different applications. This enables mission-critical services, IoT, and consumer broadband to all operate simultaneously on the same network, with each getting the resources they need. The flexibility and customization of network slicing opens up a wide range of industry applications that can benefit from optimized network performance. Edge computing brings computing resources closer to users and devices, enabling distributed computing. This reduces the distance data has to travel, resulting in ultra-low latency of just milliseconds. By processing data locally, only the most relevant information needs to be sent to the cloud, optimizing bandwidth. These capabilities enable real-time applications like autonomous vehicles, AR, VR, industrial automation, and smart cities. 5G networks will enable the massive growth of the Internet of Things, IoT. 5G provides the connection density needed to support a huge number of IoT devices per square kilometer. Low-power protocols in 5G allow IoT sensors and devices to have long battery lives, often up to 10 years. The high reliability of 5G, with 99.999% availability, is critical for mission-critical IoT applications. Experts predict there will be 75 billion IoT devices globally by 2025, enabled by the capabilities of 5G. 5G technology enables businesses to create new revenue streams and services that were previously impossible. The scalable and flexible nature of 5G networks allows companies to easily add devices and services without major infrastructure changes. The cloud-native architecture and software-defined networks of 5G reduce operational costs and simplify management. 5G's enhanced performance, with faster response times and higher reliability, leads to improved customer experiences. Transforming Industries outlines 4 key industries that are being transformed by emerging technologies. For automotive, we're seeing connected vehicles, autonomous driving, and real-time navigation. In healthcare, we have remote surgeries, patient monitoring, and telemedicine in ambulances. Manufacturing is being transformed by smart factories, predictive maintenance, and AR assistance. And in entertainment, we have cloud gaming, 8K streaming, and immersive AR, VR experiences. These are just a few examples of how technology is revolutionizing major industries. Today we'll explore how 5G is transforming everyday consumer experiences across a range of applications. First up, cloud gaming. With 5G, users can enjoy console-quality gaming anywhere, without the need for expensive hardware or lengthy downloads. The low latency of 5G enables seamless, instant gameplay. Next, augmented reality. 5G powers smooth, immersive AR experiences, with virtual objects blending naturally into the physical world. This opens up practical AR applications in shopping, education, and more. Finally, instant downloads. 5G's blazing fast speeds allow 4K movies to download in seconds, and massive files to transfer almost instantly. Constant high-speed connectivity means minimal buffering. These are just a few examples of how 5G is enhancing everyday consumer experiences. The speed, low latency, and connectivity of 5G are truly transformative. The chart shows the current global 5G rollout by region. East Asia has the highest number of 5G connections at 820 million. South Asia has the second highest at 320 million. North America and Europe follow with 250 million and 210 million respectively. Latin America and the Middle East and Africa have lower 5G adoption at 95 million and 130 million. Oceania has the lowest 5G connections at 45 million. These numbers demonstrate the uneven global progress of 5G deployment so far. The data highlights the significant lead that East Asia has established in the global 5G landscape. 5G technology is enabling a range of smart city applications that improve urban life. Connected traffic lights can adjust signal timing in real time to reduce congestion and improve traffic flow. Sensors throughout the city monitor critical infrastructure like water, power, and waste systems to detect issues and optimize performance. High-definition surveillance cameras and coordinated emergency response help enhance public safety. Environmental monitoring systems track air quality, noise pollution, and other factors to identify problem areas and inform policy decisions. This case study highlights how 5G technology is transforming the healthcare industry, enabling new e-health capabilities. Remote diagnostics allow specialists to conduct detailed patient examinations from anywhere in the world using high-definition video. Connected ambulances can transmit real-time patient data to hospitals, allowing doctors to guide paramedics through emergency procedures. Surgeons can now operate robots remotely, with haptic feedback providing them with tactile sensation during the procedure. Continuous monitoring using wearable devices tracks patient vitals, and AI analyzes the data to predict and prevent health events. These 5G-powered e-health solutions are improving access to care, enhancing patient outcomes, and transforming the healthcare industry. This case study showcases how industrial automation is transforming manufacturing operations. Real-time robotics control enables sub-millisecond latency, precise coordination of multiple robots, dynamic production adjustments, and remote expert operation. Predictive maintenance leverages thousands of connected sensors, real-time equipment monitoring, and AI-powered failure prediction to reduce downtime by 45%. The augmented workforce uses AR glasses to provide maintenance guidance, digital twin visualization, and remote expert collaboration, boosting productivity by 25%. These innovative technologies are driving unprecedented efficiency, flexibility, and quality in modern industrial settings. 5G networks offer enhanced security features that build on previous generations. Stronger authentication mechanisms help verify user identities more securely. Improved subscriber privacy protects user data and communications. Advanced encryption algorithms provide better protection of sensitive information. Secure key management ensures cryptographic keys are properly generated and distributed. Network slicing allows for logical isolation of network resources for enhanced security. However, the distributed nature of 5G also introduces new security challenges. The larger attack surface creates more potential entry points for threats. Software vulnerabilities in 5G components must be carefully managed. Supply chain risks require scrutiny of all network equipment and software. Securing the massive number of IoT devices connected to 5G is critical. Edge computing at 5G cell sites introduces new security considerations. The global 5G infrastructure investment is estimated at a staggering $1 trillion, highlighting the massive capital expenditure required for network densification. Spectrum availability is a key challenge, with limited resources and regulatory hurdles for allocation. International coordination is crucial to address this issue. Technical limitations such as wave propagation challenges, building penetration issues, and weather interference pose significant obstacles in 5G deployment. The transition to 5G will require 5G-capable devices, creating a period where mixed device capabilities need to be accommodated. The key challenge we're addressing is the gap in 5G coverage between urban and rural areas. In dense urban environments, we're using small cell deployments to boost capacity. This includes wave for ultra-high bandwidth hotspots, building-mounted small cells, and integrating 5G into street furniture. We're also enabling neutral host infrastructure sharing to maximize efficiency. For rural areas, we're taking innovative approaches to extend 5G coverage. Low-band spectrum provides wide geographic reach. Dynamic spectrum sharing helps optimize limited spectrum resources. Fixed wireless access brings broadband to remote locations. Satellite integration complements terrestrial networks to reach the hardest-to-serve areas. 5G networks are much more energy efficient than previous generations, reducing the carbon footprint of our communications infrastructure. Connected sensors and smart grids enabled by 5G can optimize resource usage and reduce energy waste, supporting sustainable practices. Reliable 5G communications improve disaster response and coordination, helping with search and rescue efforts. Remote access to education and healthcare made possible by 5G can reach underserved communities, reducing barriers to essential services. The future of wireless technology is an exciting and rapidly evolving landscape. We're currently in the 5G era, with 5G Advanced capabilities coming soon. 5G Advanced will bring enhanced features, expanded IoT support, and greater efficiency through AI integration. Looking ahead, we'll see 5G satellite integration for seamless global coverage. In the late 2020s, pre-6G research will explore cutting-edge technologies like terahertz communications and quantum networking. The ultimate goal is the launch of 6G in the 2030s, promising sub-millisecond latency, terabit speeds, and immersive holographic experiences. This timeline outlines the key milestones as we progress towards the next generation of wireless technology. 5G is a complex ecosystem with many key players working together to advance the technology. The main categories of players include network equipment providers, chipset manufacturers, standards bodies, and mobile network operators. Some of the major companies in this ecosystem are Ericsson, Qualcomm, Nokia, Huawei, Samsung, Verizon, AT&T, T-Mobile, and China Mobile. These companies all have important roles to play, from developing the network infrastructure and devices, to setting the technical standards, to deploying and operating the 5G networks. Collaboration between these diverse players is crucial for 5G to reach its full potential and be successfully rolled out worldwide. 5G represents a transformational leap forward in connectivity and technology. It will enable a wide range of innovative applications and use cases that weren't possible before. 5G's ultra-fast speeds, low latency, and massive connectivity will create a truly connected global society. This ubiquitous connectivity will drive the development of new industries, business models, and economic opportunities. In summary, 5G's technological foundation, connectivity, and economic impact make it a game-changing technology for the future.